Hi, once again, I'm Sanja Scepanovic. It's my pleasure to talk to you today about sustainable AI. And as Liz mentioned, I come from Nokia Bell Labs in Cambridge, UK. I'm part of the Responsible AI team. Before starting the discussion about sustainable AI, let's just quickly define sustainability. So we're going to take this very broad definition from 1987, which is one of the most commonly used definitions. So sustainable development is that which meets the needs of the present without compromising the ability of future generations to meet their own needs. And this definition has underpinned some of the most important frameworks, such as the UN Sustainable Development Goals that we have today. Okay, so how about AI and sustainability? Let me start with one example. One of the biggest AI companies nowadays, Google, some 5 years ago, announced that its carbon footprint is zero and it was committing to a net zero emissions by 2030, which means also data centers to be carbon neutral and their offices, which is great. And indeed, some years ago, many of these companies we could have said are really sustainable. However, the same news media, the same company, 4 years later, and not only that Google didn't come closer to its net zero, the company drastically increased its emissions 48% in these several years. And this is not to criticize the company, this has happened with several others, but this is to highlight one trend that has been happening in the AI, which perhaps many of you can guess what it is. So several years ago, we got introduced to the generative AI and large language models and chatbots. It turns out they are changing the sustainability picture of AI. Now, let me go back just to say exactly how we are going to discuss sustainability. So in general, there is this other definition which is appreciated a lot and which says that we should not think about sustainability narrowly, which is, what we commonly think environmental one. This is definitely one of the pillars. And we want to preserve biodiversity, protect us from climate change. However, there is also the societal aspect. So we want sustainability to incorporate social equity, cultural diversity, justice. And not least, we also want to have economic viability of our development, which means satisfaction of basic needs, increasing useful goods and services. So it's a very broad definition, and taken like this, let's take a look at how AI comes to picture. So here I'm really giving only some examples. So the three pillars are represented with the big circles, and the small circles represent many possible uses of AI. The white ones will be, in my opinion, beneficial, whereas the black are the risky uses that we should consider. So if we start just as an example from the society pillar, medical image analysis promises to speed up diagnosis, save lives. I think this is really a beneficial, sustainable AI use. However, in the same domain, I'm sure you have all heard, AI can be and is used for misinformation, so it's very risky. If we turn to the domain of economy and our workplaces, in my personal experience, coding assistants, in particular for low-stakes scenarios, have been really sustainable. They have made work easier, speed up. But this same process needs to be considered with the risk of skill atrophy. And this is something that's being suggested to started happening. And actually, the colleagues at Uehiro are studying and discussing this a lot from the ethical perspective. But last, and which is going to be the focus of my talk, as I think when we said sustainability, this is probably what many of you expected, we are going to talk about the environment. And again, there are many beneficial uses of AI. Proponents of AI promise that improving energy efficiency with AI, monitoring climate, supporting urban development, this is all going to drive sustainability positively. However, there are risks, and I'll discuss some of them. The main in the topic will be the environmental footprint of AI. Before diving into the concrete footprint, let me just say why this topic is so important in these bite-sized ethics seminars, why it is so much related to the topic of ethics. I argue, and also the paper that I'm citing below by some of the leading AI researchers on sustainability, they argue that AI sustainability and AI ethics are deeply interconnected and they need to be considered more so. However, AI community has up to very recently treated them mostly separately, and I'll give you some examples. So first of all, the researchers and the companies in the last maybe 5 to 10 years have started to put up so-called AI ethical principles, and often they ignored sustainability. On the other hand, there is an increasing trend of calling for green AI. So let's have efficient, sustainable AI. But usually in this field, social and ethical issues are not enough brought into consideration. And last, there are not many AI regulations, but one that's recently quite prominent is the EU AI Act, and many others. They usually have no official provisions for AI sustainability. So let me just show you concretely. This is just like examples put up in terms of ethical principles by IBM. And they say that their principles include explainability, fairness, robustness, transparency, privacy. You see no sustainability mentioned. Quickly, let's take a look at Microsoft's fairness, reliability, privacy, inclusiveness, transparency, accountability. Again, not really an explicit mention of sustainability. Now I'm going to do self-promotion of my company. It's something actually that I understood while preparing this talk. We were one of the early ones. So these principles are not new. They are here maybe 4 years on our website. We actually did put sustainability, and here credit goes to my colleagues who have drafted these principles for Nokia. And I think it's really great also to see that they have defined sustainability quite broadly, both in terms of societally sustainable AI and environmentally sustainable AI. But this is more of an exception. In terms of the second point, so research in general didn't give so much focus, I mean AI research, to this sustainability issue. In this fact paper that I'm citing at the bottom, one of the leading researchers, Birhane Abiba and others, they have analyzed 100 top AI papers, and they found that researchers, when they put their values for this AI work, they've never mentioned sustainability. On the other hand, I did mention that there is this new field of so-called green AI, and this is something very commendable, introduced by Schwartz and others in 2020. This field has been growing. Their main suggestion was before, AI was mainly benchmarked in terms of accuracy, in terms of how quickly things can be done, but not in terms of energy efficiency. And they argue that this should be an equally important benchmark. So this is great, but the field still omits broader ethical considerations. And finally, in terms of the regulation, the closest to me and the one that we studied a lot is the EU AI Act. It's also, I think, the first major regulation that's really put to practice. And there is no provisions for sustainability. There is only one article, Article 40, which mentions vaguely requirement for standardized reporting, but this is based on voluntary codes of conduct, which are not always very effective. And actually, they apply only to so-called general purpose AI. That would be the foundational model behind ChatGPT, but not all the other myriad of generative AI applications. So basically, the companies do not have at the moment really strong regulation pressure. Okay. And so now, as I said, I'm going to focus on this environmental footprint of AI and to give some arguments as to why this is a really important question today. So what's this footprint? What it consists of? Again, I'm citing the work at the bottom, which I base this on, in addition to some other resources. The first part is obviously energy consumption. Data centers consume lots of energy. Related to that, depending on how these data centers are powered, there can be a lot of greenhouse emissions. There are also embodied emissions of the products that are used for AI. Interestingly, and especially the newer type of Gen AI, there is really high water demand. Then something that's maybe not so commonly known is the rare earth metals demand. And then there are some others which I will not focus on more, but AI enables oil and gas extraction, making it more harmful for the environment in some ways, or it contributes to electronic waste. But let's quickly dive deeper into these points. So, as I said, AI energy consumption comes mainly from data centers. And what has changed in the last 4 to 5 years is that, let's call them traditional, maybe CPU-based data centers, they have been replaced by the modern GPU units data centers, because this is the type of hardware that powers the generative AI applications. And it happens so that this is much more energy consuming. On our end user side of things, we can see that in this way. If I was searching for a recipe on Google, and then maybe I did a similar search on ChatGPT, I don't know if you have any guess, but estimates are that this would spend 10 times more energy. And we are not even sure because there is not enough transparency and depends on the models behind. But researchers estimate that for the same type of application in general, compared to traditional AI, Gen AI can spend 30 to 50 times more energy. So International Energy Agency estimates that currently out of the total world energy consumption, 2% comes from AI. I do not know if this is large or not, but what they also say is that there is a prediction that only by 2026, this will double and exceed the consumption of a country of Canada. This does sound a lot. Now I'm going to the second point, so greenhouse emissions. And in addition to Google, so it was totally not an isolated case, or many other companies, Baidu, Microsoft, others that I'm not listing, have experienced the same growth in their emissions, which they reported in their SDG reports. And then let's move on to water. Here I'm citing Bloomberg investigation. They have looked at the US, and they have looked at where new data centers are being built or planned to be built. And interestingly, they find that this very often happens to be in the areas which are already water strained. And as I mentioned, the data centers' demand for water has increased with GPU so much. Before, maybe they could have cooled this in some other ways, but nowadays they need to cool with water. And the last that I will discuss, but not probably the least, which is something that I've also learned while preparing this talk, there is a lot of rare earth metals, cobalt, lithium, gallium, germanium, which are needed. They are needed either for GPU units or maybe for self-driving cars, maybe for our phones. And it turns out that they can be, and they often are, mined in unsustainable and opaque ways. So this is just a picture of a cobalt mine in Sudan where people work in really hard conditions. To me, this feels close, but if it's not, I'm going to give you one closer example. So lithium is quite scarce, and I'm from Montenegro. This is my neighboring country that I've been many times to, and I feel strongly about the case where there is now a plan to build a lithium mine, which is very likely to have high environmental damage by one of the leading world mining companies. Local people are protesting, and it's not clear what's going to happen. So I think this really gives the example of how these AI demands and the need to progress with AI are resulting in local conflicts and issues. Okay, but now I have to say, I study AI and I'm an optimistic, even if it didn't sound so far, in terms of how we will integrate AI in society. I think that there are indeed so many beneficial applications, and I will show you some now. And I also trust that we, like those of us who study research like this, the ethics people at Uehiro and other Oxford institutes, can and will hold the developers accountable and hold the industry accountable. I'm pretty sure that we will find a way. So let me now give you some positive examples. So this urban monitoring and climate monitoring, as Liz has mentioned, this is usually done from space. And I have some background also from in a space company and the university. And we recently, now I'm citing our own work, we recently studied AI applications on satellite data, which are promised to make us more sustainable, basically make our life more sustainable. So yeah, in this paper, what we did is we first identified over 100 AI applications for satellite data across various domains. And then we classified the likely risk level of these applications as per the EU AI Act. I will not now dive deeper, but EU AI Act takes into consideration the human rights impact to decide whether something is high risk or not. So if it's likely gonna infringe on some human rights, then it's risky. And what we found is maybe a positive picture, right? Majority were limited or low risk as per our analysis, but there were some, and interestingly, mostly upcoming, so kind of newer types of applications that were high risk and even could be prohibited. A quick summary, and then I will dive deeper. Low risk turned out to be supporting sustainable urban development, climate resilience, citizen well-being. High risk, however, had to do with privacy and surveillance, power imbalance. But I will dive deeper now. For the low risk one, we did this mapping to the right to the how much these application or how many of these applications would support sustainable development goals. And what we found is that some of the goals, such as 11 sustainable cities and communities, or 15 life on land, or 6 clean water, 7 affordable energies, they are quite supported, promoted by these uses, which is great. An example of the uses would be mapping urban growth with satellite data, tracking carbon emissions, maybe of companies, detecting structural anomalies using radar data, identifying maybe human trafficking networks, this is discussed in research, estimating water sources from multispectral data. But then let's take a look at what could be high risk or prohibited uses. So here I want to highlight that satellite data are becoming of increasingly higher both spatial and temporal resolution. So this is something to have in mind. So, for example, from drone imagery, there is already a possibility to do facial recognition. And to those of you who are familiar with the EU AI Act, anything that includes surveillance and facial recognition is prohibited, which we think is great. But also, even the applications that maybe sound, they would be like really useful, monitoring illegal activities, they can become illegal if they turn out to be a surveillance type of police state. Any demographic analysis from high resolution would be also prohibited. In terms of high risk, these are the ones that we maybe want to develop, and I will argue that some of them we want to develop. There would be, for example, workforce monitoring. You can imagine a mine, you can imagine a construction site, a warehouse. Critical infrastructure monitoring, this is, monitoring the state of bridges, maybe buildings, maybe roads. This is, as per the EU AI Act, high risk because of the importance of this infrastructure, and then law enforcement applications and so on. And I want to say that some of the Earth observation experts we interviewed, they said that despite some applications being high risk, it would be equally risky if we wouldn't implement some of them. So I think this is also important to have in mind. So maybe analyzing why there are these risks, the underlying human rights issues or the underlying problems, they stem usually from privacy and surveillance, unsurprisingly, but also data ownership and power imbalance. Here, the countries that can afford to do satellite imaging and Earth observation, they might be monitoring themselves, or they might be monitoring somebody else who might not want to be monitored. And there is also this power imbalance, what happens with the data. Very important data biases are usually discussed, for example, racial bias and so on. But geographic bias is a big issue, and all the applications that promise they're going to solve climate change, they also we have it as an unsolved problem as to how the models trained in one area will transfer to another. This so far does not work so well. There are also vulnerable subjects and communities. Think of slum monitoring and think of the impacts. Maybe the state will want to displace those people. Then, as with any other type of AI, what if the ones who use it over-rely? And then specific to Earth observation, there can be this detachment from on the ground, because those who are analyzing the data, they might be sitting at the comfort of their home, but they might be observing some global South community and might not really understand the subtleties. Okay, so this was like our analysis of pros and cons of this AI for satellite data. And I'm going to conclude with one also like a positive example, which was improving AI energy efficiency with AI. And this is going back to the company I mentioned before. So they are amazing research lab, DeepMind. In 2016, they have implemented this AI framework, which reduced energy consumption in data centers related to cooling by 40%. So this is really amazing, but still let's understand that this was 2016. Up to now, the company has increased the emissions, which I think brings us back to the importance of this topic of sustainability. And with that, I will conclude with my take on the state of AI sustainability, which is that avoid AI research and deployment without proper environmental considerations, they could deepen inequalities, they could worsen the climate problems that they promise to solve. And that's why both research and industry, they really need to become more transparent and more comprehensively to measure and address its actual impacts before claiming to offer other solutions. Thank you so much for listening to my talk, and I welcome any questions you might have.